there were some doubts about the realness of this product and the boards themselves. So here, instead of a 3D render, I'd like to show you the actual board. This is one of the prototype boards, so it's missing the button. The button's an LED, also has a couple of minor fixes on it. But that's the DVI based board. The DisplayPort based board is here. Has the exact same pinout, form factor, basically everything's the same except for the DVI plug. There are a couple of bare PCBs, no population, just some spares. This is hooked up with the video cables. There are two cables, each doing 2-channel videos. This is the M270HHF-L10. The power supply that I'm using is a generic off-the-shelf, AC to 12 volt plus LED driver integrated. So there's the LED connector there, this little custom cable job connecting into that. You can see right now I only have one display plugged in. I'm going to plug in the ZisWorks board. Alright, and we're going to see that appear here. Z's 1080p 240. And lift that up. Get a nice image there, same background. If we look at the serial console output, we see that the board booted up, powered on the panel, initialized the video chip, got some frames, and got a lock on the video timings. So if we look at the NVIDIA control panel, we'll set this to the native modes are 240 or 120. I also have a custom mode for 270 Hertz. That doesn't play well with the Chrome test, so I'll leave it at 240. Okay, 240 Hertz. There we go. To show that that's actually working, we're going to go to Test UFO. We're going to go to the frame skipping check for display overclocking. Of course, the bigger display here is sitting at 60 Hertz. No real surprise. We will have to switch to single monitor mode in order to operate at the 240 Hertz. So this is trying to sync. This Blur Busters test shows skipping when you see a hole in this sort of gray line scanning through. What happens is during every frame, one white box is on and the rest are black. So one box is white, the rest are black. In the next frame, the next box will be white, and the previous one will be black. And this white box just travels across this grid. And you can visualize frame skipping by seeing a hole in this array. So right now we see 240 Hertz. I'll turn off the light so that the camera can pick it up a little easier. As you can see, there's no frame skipping going on. This is 240 Hertz. This is very fast. And NVIDIA has no problems running it. The only thing you need to do is run the Pixel Clock Patcher from ToastEX. It has both Radeon and GeForce Pixel Clock Patchers. You run that and it's plug and play. There's no fuss. So, once again, I'll show the connections in the back. That's the board. That's the USB to serial adapter. Pretty standard part. I think this one's from Adafruit, but you can pick them up pretty much anywhere. A couple bucks. I'll unplug the DVI here, and my other monitor will turn right back on. There you go. So, there's no screwing around here. The product is real. I almost forgot to show the 270 hertz. So, right now I have this as a custom mode. It's not in the EDID, so we'll select that. Apply it. Let's see that we just lost lock and got lock again. Go back to test UFO. Usually this doesn't like to sync at 270, but I'll try to show it. Oh, it worked for a second there. But just like before, it's not doing any skipping, and it is operating at 270 hertz. At 270, there are very minor glitches occasionally. I'm not sure if we'll be able to see any here. Usually they're most visible in text. Yep, I'm actually not seeing any on this image.